Hi guys, and welcome back to the ACE Academy. In this video, we'll be looking at sketching a parabola using a given equation, as well as using a given sketch to obtain the equation for a parabola. Now, in the first part of this video, we'll be focusing on sketching a parabola using a given equation. So as you can see on your screen right now, there are two equations for two different functions that we are going to sketch on this empty and blank Cartesian plane. The first equation is f of x is equal to x squared minus 2x minus 3. Now, what I want you guys to take note of is the notation that I am using. Previously, I would have used, for f of x, I would have used y instead. But in this case, I'm going to be sticking to this functional notation. Essentially, f of x is essentially saying you, this is the y value for the equation of f, right? And in the second equation, you can see it is labeled g of x. G of x is essentially telling you that these are the y values for the equation of g. Understand? So this is just a method that we use in order to define the functions that we have on our Cartesian plane when multiple different functions are present on the same Cartesian plane. So what I'm going to do is I'm going to walk you guys through plotting a parabola using a given equation step by step. Let's look at the first equation, the equation of f. We can see that f of x, or y, is equal to x squared minus 2x minus 3. Now this equation is quite powerful because using the single equation that we have been given, we are able to plot the shape of this function. The first thing I want you guys to take note of is the minus 3 right here. Now this minus 3 is important because it tells us our y-intercept. So let's come to this Cartesian plane over here and estimate a value of minus 3. We know our y-intercept is going to be at an x value of 0 and a y value of minus 3. Okay? The next thing that we are going to do is we need to look at the important points for any parabola, and that would of course be its x-intercepts. It will have two x-intercepts, its y-intercept, and its turning point. Because using those, I want to say 3, but it's actually 4. Using those 4 points, I would be able to obtain the shape of this parabola. In fact, we don't even have to go too much into shape using mathematics because it would be plotted using these points. Okay guys, so using this equation of f, we now have to obtain the x-intercepts for this function. And that can simply be done by changing this equation into its x-intercept form, its x-intercept standard equation. And this is done by factorizing the entire equation. Now, there are many ways to factorize this equation. It can be done using inspection. It can be done using the quadratic formula, which is x is equal to minus b plus minus root b squared minus 4ac all over 2a. That is a formula that you guys would be familiar with by now because that's what we use to obtain the solutions for a complex quadratic equation. Or you guys can simply do it using your Casio calculator, specifically the FX991ZA Plus and the FX991ZA Plus 2 calculators. So what I'm going to do quickly is I'm going to bring up my calculator emulator and I'm going to show you guys how to use the calculator to obtain your x-intercepts. So guys, look at this little block that I have put onto your screen right now. Now, in order for you guys to obtain the x-intercepts using the calculator, you would simply look at your calculator keys right below the screen next to the up, down, right, left arrows on your calculator. You would see a button called mode. And all you're going to have to do is click that button and it would take you to a menu that would allow you to select the type of mode you want to put your calculator in. And what we are interested in is number 5 right here, because number 5 is the one that is going to allow us to get the x-intercepts of our quadratic equation. or of our function rather. So we are simply going to select 5. So go to your calculator, tap 5, and you are going to, yeah, just go to your calculator and tap 5, right? And it'll give you all of these options right here, the 1, 2, 3, and 4. You are going to be looking at number 3 right here. The third mode in this form of your calculator, as you can see, has the standard equation for your parabola: ax squared plus bx plus c is equal to 0. So what we're going to do is we're going to select 3. So just tap the 3 key on your calculator, and it will prompt you to a screen that looks like this. You can see you have A, B, and C, and beneath that you have your individual values. So if we look at our standard formula for the parabola, that is ax squared plus bx plus c, we are simply going to substitute in the A, B, and C values. So let's do this for this equation that we're working with. We know that our A value is positive 1 because in front of the x squared we have a positive 1. So I'm going to type in 1 and then I'm going to tap equals to, right? That will move me on to the value of B. Let's look at the value of B in this equation. The value of B in this equation is negative 2. So I'm going to be very careful, and I'm also going to type in the sign associated with B and not just the value of B. So that would be negative 2. So I would type in negative 2 and tap my equal to sign. Now let's look at the value of C. The value of C is negative 3. So I would type that in, negative 3. I can tap my equal to sign and tap it again. And we can see the first value for x, my first x-intercept would be x is equal to 3. Okay, and I'm going to bring that back quickly. And if I tap equal to again, I would see that my second x-intercept is x is equal to negative 1. Okay, and I can plot that in quickly. So let me estimate it and say x is equal to 3 is here, and x is equal to negative 1 is here. And I have now obtained my x-intercept for this function. In order for me to show my steps of how I got to this point, I would simply work backwards. So this would now become x minus 3 is equal to 0, and x plus 1 is equal to 0. And I would work backwards a bit further, and I would get x minus 3 times x plus 1 should equal to 0. And that is my steps as to how I factorize this equation to obtain my x-intercepts. It's quite simple with the calculator. The more you do it, the more familiar you become with the method, and it becomes second nature to you guys. So that's the first step in order to calculate your x-intercepts for the function. Right? The next thing that we're going to do is we are going to look for the turning point of this function, right? So the turning point lies exactly between my x-intercepts. That is its x value. So in order for me to calculate the x value of the turning point for this function, I would simply say 3 plus minus 1. Those are my two x-intercepts, and I divide that by 2. And I would obtain 2 over 2, which is equal to 1, and that is the x value of my turning point. In order for me to obtain the y value of my turning point, because I need a coordinate for my turning point, I would just substitute 1 into x in my original formula, and that will give me my y value on this function. So looking at f of x is equal to x squared minus 2x minus 3, I can substitute in positive 1. So y would be equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 times 1 is minus 2. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So simply y would be equal to negative 4. And my turning point's coordinates would be 1 and negative 4. it really is quite simple. So I'm going to look for 1 on my Cartesian plane, and I'm going to bring it, and I'm going to look for a y value of -4, and I'm going to plot that in. And now essentially what I can do is I can just go ahead and join those points and I have obtained my function for f of x, which is a parabola that has a smiley face shape. So simply by using the x-intercepts, by finding the x-intercepts of this function, finding its turning point, and finding its y-intercept, I'm able to sketch the function. Now, the method that I showed you in order to calculate the turning point, to get the coordinates of the turning point for the function, is my own method. In school, you guys would learn this formula right here, which says that the x value of the turning point is actually minus b over 2a. And that b value would be your -2, so that would essentially be minus 2, which is +2, or over 2 times a, which is 1. So that would be +2 over +2, which is equal to 1. And you can see that we obtain the same answer. My method uses logic because it tells you that the parabola is symmetric about its turning point. So essentially what that means is its first x-intercept, or its x-intercept towards the right, would have the exact same distance as the distance between the x-intercept to the left and the turning point itself. That's basically the logic that I use in order to obtain it, but this formula is also acceptable, so you guys can go ahead and use whichever one you feel most comfortable to use. Okay, so looking at the second equation that we have on the screen, and that is for the function of g of x. This equation is g of x is equal to 2x squared minus 8x minus 10. You guys can take a second and try this yourself to see if you'd understand what to do. But so you guys can pause the video and attempt it. But I'm gonna go ahead and explain it right now. Okay. We're gonna use the same approach. We're going to identify its y-intercept, which is -10, and I'm just gonna estimate it here. That was 1, 2. I would say -10 is about there. Now I'm going to go ahead and calculate its x-intercepts, and that can be obtained by factorizing, again using the same method. You can also use the quadratic formula if you guys don't have an FX991ZA plus calculator. You can go ahead and use the quadratic formula. You would obtain the same result. Right. I'm just gonna go ahead and cancel this quickly. And now you can see when I put my calculator on, I'm returning to the exact same mode that I previously was on. So I can simply redo the inputs for A, B, and C. So in this case, A would be 2, B would be -8, and C would be -10, sorry, -10. And if I go ahead and prompt my calculator to do the calculation by pressing equals to, I can see that my first x-intercept is at x is equal to 5, and my second x-intercept would be at x is equal to -1. Okay, so I can go ahead and plot that in really quickly. Let's look at it. X is equal to 5, so that was 3, 4, 5. I will plot that in there. X is equal to -1. I can plot that in right there. If I work backwards, of course, I can obtain my factorized term. So I can say x minus 5 is equal to 0. X plus 1 is equal to 0. Then moving on, I can then bring in my brackets, and I'll get x minus 5 times x plus 1 should all be equal to 0. And that's my factorized term. Okay, I can now go ahead and find the turning point for this function. I'm going to use my preferred method, which is adding the values of the x-intercepts and dividing by 2. So that would be 5 plus minus 1 all over 2, and that would be equal to +2, because 5 plus minus 1 is 4, and 4 over 2 is 2. You can also use the minus b over 2a method. So I can say minus negative 8 over 2 times 2. Minus negative 8 is actually positive 8, 8 over 4, and 8 over 4 is equal to 2. It's the same thing, guys. It's essentially the same thing. Okay, now in order for me to calculate the y value of my turning point, remember this is only the x value of my turning point. I would have to find the y value at x equal to 2 on this function. For me to do that, I would use the equation of my function. So I'd simply substitute 2 in for x. Substituting 2 in for x, I would get y is equal to 2 into 2 squared minus 8 times 2 minus 10. So 2 times 2 squared. 2 squared is 4. 2 times 4 is 8. Let me write that down quickly. Okay. And then you have negative 8 times 2, which is negative 16. And you're going to minus a 10 from that. 8 minus 16 is actually negative 8. Negative 8 minus 10 is negative 18. And of course, I can't plot this on my Cartesian plane because I did not estimate correctly, but I'm just going to go ahead and act like I did. So I'm just going to plot the point somewhere around here. Okay. That's my turning point. And now I can simply draw this in, guys. It's quite simple. So I'm going to start off here, and I'm going to just draw in my function. That is the function of g of x, guys. Remember to label your turning points. Always put the coordinates of your turning points down when you are asked to sketch a function. Label your x-intercepts and your y-intercepts. If you do all of those things, I can guarantee you guys that you would get full marks for sketching this function. Alright, so that is the first part of this video completed. We are now going to go ahead and move on to obtaining the equation of a sketched parabola. Alright, and that one's a bit tricky, but don't worry, we are going to try to make it simple and fun. Okay guys, so this is now the second part of this video, and we are now going to be focusing on obtaining the equation of a parabola using a given sketch. So on your screen right now, you guys can see we have a parabola that has been sketched for us, and let's just look at the type of information that has been given. We can see that we are given the x-intercepts of this parabola as well as a point on this parabola. Now, there are two ways in which they can ask you this question. And the difference between these two ways in which they can ask you this question lies in the information that they give you. In this case, as we have already said, they have given us the values of the x-intercept and they have given us a point on this function. The other way in which they can ask you this question is by giving you guys the value of the turning point and some other point on the function, right? And we are going to cover both ways and the manner in which to answer these questions. So, looking at this parabola that is sketched for us, we can see that due to the fact they have given us the x-intercepts, we can use the x-intercept form or the x-intercept standard equation for a parabola in order to solve this. So let's write that down quickly. The x-intercept standard form of a parabola is y is equal to a into x minus k1 times x minus k2. And the value of k1 and k2 are just the x-intercepts value of the parabola that has been given to us. And it doesn't matter which one you assign to which. So negative 3 could be k1 and 5 could be k2, or you could switch around its position. Because it is multiplication, it does not really matter, just the fact that you use both values. So let's go ahead and substitute in these points. Okay, I'm going to say negative 3 is my k1 and positive 5 is my k2. So substituting into this formula, I would get y is equal to a into x minus negative 3. I must keep the sign. If I don't keep the sign, I will not get the correct answer. So it's x minus negative 3, and that would be multiplied by x minus positive 5. So a good way in order to substitute these correctly is to keep them in their own individual brackets. That will make sure that we are keeping the correct sign convention so that we don't mess up our calculation, right? Now, in order for me to obtain the only unknown that I need to find in this equation, which is the value of a, that given point on this function will come in handy. I can now substitute in the point x value of positive 4 and y value of positive 14 into this equation to obtain my a value, or to solve for a. So the way I would do this is, I know that the y value of this point is 14, so I will substitute in 14 for y. Then I would continue writing the equation as it was written above, and for every x value I would now substitute in the value of positive 4, which is the x value at that point. So this would become a into 4 plus 3, and that is just because of the negative and negative sign associated with the positive, associated with the value of 3. So I would get a into 4 plus 3 times 4 minus 5. And I can simplify further. I would get 14 is equal to a into 7 times, what is 4 minus 5? Negative 1. And that is simply 14 is equal to negative 7a. Okay, 14 is equal to negative 7a. I'm solving for a, so I want to isolate the value of a, and that would leave me with a value of a is equal to 14 over negative 7, which is equal to negative 2. So the value of a is now negative 2. What my next step would be to substitute in the value of a, which is negative 2, for a in the expanded form of this formula. So I would be left with y is equal to negative 2 into x plus 3 times x minus 5. Okay, and the only step that is left for me to complete to obtain the equation of this parabola is for me to, of course, expand and distribute, and I would obtain y is equal to negative 2x minus 6 times x minus 5, and expanding further, I would obtain y is equal to negative 2x squared plus 10x minus 6x plus 30. And I can simplify that because I have two like terms, and essentially my equation would be y is equal to negative 2x squared plus 4x plus 30. So that is how I would obtain the equation for this given parabola using the information that was given to me, which was my x-intercepts and a point on the parabola. From this equation that has now been that I have now obtained, I can of course see that the value of the y-intercept is positive 30. So this point right here would be positive 30, right? In order for me to obtain the turning point of this function, if it was asked to me in my exam paper, I would use the minus b over 2a formula to obtain its x value, take that x value, substitute it into the standard formula that I've now obtained, and I would obtain its corresponding y value in order for me to create a coordinate. The other method in order to find the turning point is to, of course, add the values of the x-intercepts, divide that by 2, and that will give you the x value of your turning point. To find out what point that lies on, what y value that lies on our function, we would of course substitute it into our formula to obtain its corresponding y value. It's quite a simple method. I know it is a mouthful, it definitely is, but once you attempt it yourself, you would see how easy it is. In simple terms, in order for us to obtain a corresponding y value on a function for an x value, all we would have to do is take the x value and substitute it into the formula of the function, because that is as simple as it gets. Guys, we are trying to find the corresponding coordinate for any value on our function. So we have completed the first type of approach they can question you on for obtaining the equation of a parabola using a given sketch. We are now going to move on to the second type of approach they can question you on in your exam paper for this section. Okay guys, this is now the second type of approach they can use in order to question you on obtaining the equation of a given sketched parabola. And in this type of approach, they have now given us the value of the turning point of the parabola and another point on the parabola itself. In order for us to attempt this type of question, we would have to think about the information that has been given to us. And like I have said, we have now got a turning point of this parabola. That turning point is extremely important because it means we can now use the turning point standard form of the parabola, which is simply y is equal to a into x minus p squared plus q. And in this form, the p value is the x value of your turning point and the q value is the y value of your turning point. So let's go ahead and attempt to obtain the equation for this parabola. My first step would of course be to substitute in the value of my turning points into this function, and I would get the equation y is equal to a into x minus, and what is the value of the x value of my turning point? The x value is positive 1, so I'm going to substitute in positive 1, and I'm going to square this entire bracket. And the y value of my turning point is 32, so I'm going to substitute in 32. So that is now my equation for this parabola. I of course have an unknown that I need to solve for, and that is the a value, because the only unknowns that I want in this equation is my x and my y. In order to do this, the point that has been given to us on this function would come in handy. We are now going to substitute in that point in order to solve for a. So let's go ahead and expand this bracket firstly, just to make life a bit simpler. We would get y is equal to a into x minus 1 times x minus 1 plus 32. X minus 1 times x minus 1 would result in a answer that looks like this. X times x would of course be x squared. X times negative 1 would be negative 1x, and negative 1 times x would be negative 1x. Negative 1x minus 1x would be negative 2x. So I can just simplify it without writing it down. That saves me a step. And then negative 1 times negative 1 is positive 1. And of course I would rewrite the equation as was given. And my new equation would be y is equal to a into x squared minus 2x plus 1, close brackets, plus 32. I will now substitute in the point that was given on my function, which is 4 and 14. 14 would be my y value, so substituting that in, 14 is equal to a into, my x value was 4, so 4 squared is 16. Negative 2 times 4 is negative 8. And I'm going to add 1 to that. And of course, I'll have my positive 32. Moving a step further, 14 minus 32, I would have to put that down first. 14 minus 32 is equal to 8 times 16 minus 8 is 8. 8 plus 1 is 9. And 14 minus 32 is negative 18 is equal to 8 times 9. So if I simplified and solve for a, I would get negative 18 over 9 is equal to a. And therefore, a is equal to negative 2. Now that I have solved for the unknown that I wanted to get rid of, I can now go ahead and substitute that into my standard formula, and it would now look like this. Y is equal to negative 2 into x minus 1 times x minus 1 plus 32. Expanding and simplifying, I would obtain y is equal to negative 2x plus 2 times x minus 1 plus 32. And expanding and simplifying, I would come to the equation y is equal to negative 2x plus 4x plus 30. And that is it, guys. It is that simple. If I wanted to find the x-intercepts for this function, I would of course factorize the standard equation, bring it to x-intercept form, and find the corresponding x-intercepts. It is quite easy to approach this section. I know it can be daunting at times because it looks like a lot of work, but with enough practice and some confidence, I'm sure you guys would find this section quite simple. That's it from me, guys. All the best, and I will see you in the next one.